Today, we are going to start with confidence intervals. In this session, we are going to look at the estimates which will be used in conjunction with population parameters. We're going to be looking at the point and the interval estimate. We will create a general estimation framework. For this, we would need to know about confidence intervals, confidence levels, margin of error. And once we have this general framework ready, we will be able to interpret the confidence intervals. Now we're going to look at statistical inference. Let's take an example. Suppose if I want to find out the average age of students in a university doing their bachelor's in US. Now that's a very, very difficult task because we all know there are so many universities, so many students. So what we normally do is, in order to make some kind of analysis for such a huge population, we take a sample set and then we use that to make inferences about the whole population. So that's why statistical inference is a very important part. Here it tells us methods to make conclusions about a population from a sample data. Now, there are many population parameters we have learned about, like mean, we have learned about standard deviation, median, proportions. So when we are using statistical inference, so we would like to make estimation about these population parameters. So for example, we would use a sample mean to estimate a population mean, a sample proportion to estimate a population proportion. So what we basically do in these inference methods, we say how close a sample statistics will fall within a population parameter. That is the main idea about statistical inferences. Let's start with a very simple example. An example related to healthcare. Here, a study deals with healthcare issues and plans to take a sample survey of 1,500 Americans to estimate the proportion who have health insurance and the mean dollar amount that Americans spent on healthcare this past year. So our first question is, what are the two population parameters this healthcare is talking about? So we notice we are talking about the proportion who have health insurance. Here, that's one. And the second one is the mean amount, dollar amount, which an American will spend on healthcare this past year. So these are our two population parameters. One is the population proportion who have health insurance, and the other one is the mean dollar amount. Now, what would be the sample size? Now, the sample size is a sample survey of 1,500 Americans. Okay, now what would be the two statistics? Identify the two statistics which will be used to estimate these parameters. Remember, the word parameters is always used for population, and statistics is used for sample data set. So we are being asked, what are those two statistics which will estimate these population parameters which are coming from here? And that is, remember, it's a proportion, then for the statistics it will become the sample proportion. And if it is a mean dollar amount, that is the population mean, in terms of statistics it will become the sample mean. Now, statistical inference, guys, is of two types. One, in the statistical inference, that means we're using a sample to make analysis about the whole population. One would be to estimate these population parameters. That's first method. The second method is we apply the hypothesis about these parameter values. In this session and some more of these videos, we are going to be working on the estimation of population parameters. So before we really start into the theory part of it, we need to learn about some concepts which are related to the estimates of population parameters. So once again, our focus is now to work on the concepts which relate to the estimates of population parameters. The first concept is called the point estimate. A point estimate is a single number, which is a best guess for the parameters. For example, a population mean will use the sample mean as a point estimate and a sample proportion given by p hat as a point estimate for the true proportion. So what the point means, as the name is suggesting, one number which estimates the whole parameter. Now, this point estimate is not such a good one, as it does not tell how close the estimate is likely to be to the parameter, because the main idea is these methods should give us a prediction about how close the sample is to the true population. So a point estimate doesn't give us that real thing we are looking for. So before we add another concept, let's do some examples about how do we find a point estimate. Now let's take this example. It says many people think that a national lobby successful fight against gun control legislation is reflecting the will of minority of Americans. A random sample of 4,000 citizens yielded 2,290 who were in favor of gun control. We would like to find the point estimate for estimating the proportion of all Americans who are in favor of gun control legislation. Now remember, we want to know estimating the proportion of all Americans. So you are estimating for every American by this random sample. So what is the point estimate? So here the point estimate, guys, is given by the sample proportion. And that is, remember, p hat is given by that. Now we just plug in numbers. The total number is 4,000 and the ones who are in favor is 2290, roughly almost more than 50%. So 0.57, I think 25. Yeah, 0.5725. Okay. Let's do another example of a point estimate. Now, this example says, in an effort to monitor the level of lead in the air after an explosion at a battery factory, the following lead readings were taken for 6 days following this explosion in UGs per meter cube. So I do not know what UG is. Okay, that's something related to the problem here. But what the question we are looking for is, what is the point estimate for the population mean level in the air over 6 days following this explosion? So that means this, from Monday to Saturday, is our sample set. And we would like to find a point estimate for the population mean. Now remember, the point estimate for a population mean is the, so point estimate in this problem is the sample mean. As we are just given 6 values, sample mean basically here is adding all the numbers of these air level of lead, 5.4 plus 1.1 plus 0.42 plus 0.73, 0.48 plus 1.1, now divided by 6. That's how you find an average. And you get the answer to be 1.54. So this sample mean will estimate the whole population mean of lead in the air over the 6 days. As I said, that doesn't sound so well method to estimate, like you're taking the whole population and you say it is represented by one number. doesn't feel good, kind of. So we say, can we have a little leeway? Can we have some interval, a range of values for which to play with? And that leads us to the next concept, which is called the interval estimate. Now, what does the interval estimate say? It's an interval of numbers within which the parameter value is believed to fall. Now, these range of values above and below the point estimate is called the margin of error. So remember, if I have a huge data set and I say it's represented by one number, something doesn't seem to fit right here. But if I say there's a range of values over which I think that the population parameter will fall, you feel more confident there. So that's why interval estimates are more useful, because it incorporates a margin of error. That means you're adding a range of values ahead or below the point estimate. And this helps us to gauge the accuracy of the point estimate. Okay, let's do some examples here. In a recent survey, voters in one state revealed that 47.2% favor approval of an issue before the legislature. The margin of error was plus minus 2.8%. Give an interval estimate for the proportion of all voters in the state who favor this approval. For the proportion, that means for the population we're talking about, okay? So in a recent survey, so the moment you see the word recent survey, it says these many favor. So remember, the interval estimate is point estimate plus minus the margin of error. It's basically an interval. Okay, so the point estimate over here is the proportion, the sample proportion coming from a survey, 47.2%. Now guys, remember, when we write, we talk in percentage, but when we do the math, we change it to decimal. So here the point estimate is now 0.472. And then it says it's a margin of error of 2.8%. Change it to decimals. Plus minus 0.028. So what's the interval estimate, guys? It's going to be 0.472 minus 0.028, 0.472 plus 0.028. So what are our numbers? So the numbers are, the interval is 0.444 and 0.500. So remember, we have a value, or it's a range of values. Okay, now remember, we're looking for a range of values. We're looking for a confidence interval. Now, first, before we go do some problems with confidence intervals, I like to do a little bit more conceptual work. That means I'm just going to talk about some general estimation framework, which will help us do it. Now, as I said, if I want to estimate a parameter, remember parameter means it is related to population. As I also said earlier, it's very impossible to exactly pinpoint this value with 100% accuracy without sampling every single member of the population. And there's always going to be uncertainty. So what we do is, let's make a guess of a true value. And that means when you're making a guess, that will include a margin of error based on a certain level of confidence. This level of confidence is the incorporating the uncertainty. So how do a statistician work with these problems? They use something called confidence interval. This confidence interval expresses the precision and uncertainty with the help of a point estimate and the margin of error. That's what we're looking at. We are trying to estimate the population within a range of values, and we are also thinking what is the certainty or the uncertainty involved over here. So uncertainty is the one. So that uncertainty is the one which is related to how much precision can we get over there. Okay, so let's talk about confidence intervals now. As we talked earlier, it's an interval which contains the most believable values a parameter can lie in. There are three parts of a confidence interval. One is the confidence level. That's the one which takes care of the uncertainty of the sampling method. Remember, we're going to take samples. Now, every person's sample is not going to be the same. They're going to be different. Then we're going to look at the point estimate. That is the sample statistic. And finally, the margin of error. So we have three things, guys, to make our confidence interval. Let's write it down in a nice little form. So a confidence interval is constructed using this formula. A point estimate plus minus the margin of error. Now, they are much more preferred to the point estimates, these confidence interval, because it not only contains the precision of the estimate, suppose you're looking in terms of point, but also the uncertainty. And that's why the margin of error pops up. Let's do an example over here. A 95% confidence interval for a population mean has a margin of error of 3.9. If the sample mean is 54.6, obtain the 95% confidence interval. Remember, 95 confidence interval basically means that we are 95% confident that the true population mean will lie within these values. So confidence interval is what? The point estimate plus minus the margin of error. So I'm going to just keep on writing MOEs. And for point estimate, guys, I'm going to write PE. Okay. This, guys, remember, it's a margin of error. So what is the point estimate? Here we're talking of population mean. It says for a population mean has a margin of error of 3.9, a sample mean of 54.6. So population mean, the sample mean is the point estimate, and the margin of error is 3.9. Remember, it's mean, it's numbers, no percentages. That percentages are related to proportions. So what is the confidence interval? It's 54.6 minus 3.9 and 54.6 plus 3.9. So what is the final answer? 50.7 and 58.5. Okay, as we said earlier, confidence intervals, they are preferred to point estimates because confidence gives us the precision and the uncertainty of the estimate. Now, this uncertainty of the estimate is the probability part of the confidence interval, and we give it a name called confidence level. Okay, so let's give a proper definition to confidence levels. The confidence level, it describes the likelihood that a particular sampling method will produce a confidence interval that includes the true population parameter. Remember, what is a confidence? It is the, whatever method we're using, it gives us a confidence that that method will include the true population parameter. How do we interpret it? Now it says, suppose we collected all possible samples from a given population and computed the confidence intervals for each of these samples. Now some confidence intervals may include the true population and some may not. But when we say the word, I'm 95% confidence level, that I say, sometimes when you say I'm 95% confident, that means I'm having a 95% confidence level. That 95% of these intervals contain the true population parameters. So when I'm saying 90% confident, it means that 90% of all these intervals will contain the population parameter. Okay, how do we find the confidence level? We need some equations. First of all, the confidence level is denoted by 1 minus alpha. Now, alpha is the chance that it will not cover the true parameter. But 1 minus alpha is the chance it will cover. So if I say I'm 95% confident, that means 1 minus alpha is 95%. Now remember, if we want to solve for alpha, we will write it in decimals. So that means I am 5%, it's 0.05. So what is alpha? It is 1 minus 0.95, which is 0.05, which it simply says I'm 5%, I'm a little not, not okay with this kind of sampling method, but 95% of the time I'm very happy with it. Okay, and happy in the sense is that interval will cover the true parameter. Okay, now how will it show up in the formulas? Because we need to look at some formulas here. So remember when we talked about confidence intervals, what was it? Point estimate plus minus, this was margin of error. The margin of error is the one which contains this confidence level. And how do we figure, what is the formula for that? Now, margin of error is the one which can be divided into two parts. This is the value which will have the critical value, that means the z-score, depending upon what distribution we have, and the standard error of the point estimate. Now, when I say the word standard error, the standard error defined as an estimated standard deviation of a sampling distribution of the sample statistics. We use the standard error to be SE. Okay, so once again, when I say confidence interval, it is the point estimate PE plus minus the margin of error. Now, margin of error is further divided into two parts, which will have the critical value. Remember the z-scores, z alpha or by 2, or so let me write just z-scores. So it's a z-score times the standard error. Okay, this is the most important thing for us, guys. We need to know this formula. A confidence interval is a point estimate plus minus the margin of error. And when we go deeper into it, margin of error is nothing but the z-score times the standard error. When I say the word standard error, remember it is the estimated, very important, it is the estimated standard deviation of the sampling distribution. Okay. Now let's do an example to interpret the confidence interval. Okay, here it says, a local newspaper is conducting an election survey and reports that the independent candidate will receive 30% of the votes. The newspaper states that the survey had a 5% margin of error and a confidence level of 95%. So what are we going to say? So remember, let's start this one. It says a candidate is going to receive 30% of the vote. Okay, and it has a margin of error of 5%. So according to my formula of confidence intervals, which is point estimate plus minus margin of error, remember percentages means we're talking in proportions. So it's 0.3 plus minus 0.05. So that means my confidence interval is 0.3 minus 0.05 and 0.3 plus 0.05. So which basically means the confidence interval is 0.25 and 0.35. Now how do we write it? We say that we are 95. Confidence level is 95. That we are 95% confident that the independent candidate will receive between 25% and 35% of the vote. Okay, let's do another example. Now, it's projecting a winning candidate. News coverage during a recent election projected that a certain candidate would receive 54.8% of all the votes cast. And also the projection had a margin of error of plus minus 3%. The question says, what is the point estimate for the proportion if all votes that the candidate of all the votes the candidate will receive? It is simply 54.8% or 0.548. Okay. We would like to have an interval estimate. Now remember the interval estimate means what? Point estimate plus minus margin of error, which is 0.548. What is the margin of error? 3%, 0.03. So once again, the interval is going to be what? 0.548 minus 0.03, 0.548 plus 0.03, which gives me what? The answer is 0.518 and 0.578. Okay, let's do one more example, the last example in this session. The question is, we would like to estimate the percentage of APSU students who are left-handed. Now suppose we took a sample of size 100 and found that 15 students were left-handed. So what is the proportion, the sample proportion? The point estimate is 15% or 0.15. Now we also calculated a critical value of 1.645, a standard error of 0.0357 with a confidence level of 95%. We would like to find the confidence interval. Remember confidence interval. Now remember here we're not given the margin of error detail. We are given the parts of the margin of error. So first let's write down the formula and then we go and plug in the numbers. It says point estimate plus minus margin of error equals the confidence interval. What is the margin of error comprised of? If you go back in previous slides, it's z-score times standard error. A z-score, remember, is the critical value. That's what we call a z-score to be, a critical value. So z-score is 1.645. The standard error, remember, it's the estimation of the standard deviation of a sampling distribution. That is where it's going to be. So standard error is 0.0357. Plugging in these two numbers gives me the margin of error. And then you add or subtract to the point estimate 0.15. When you do the math, you find that the interval is 0.15 plus minus 0.0587. Very simple addition and subtraction. The interval is 0.0913 or 0.2087. Now, how do we interpret? We say we are 95% confident that the true percentage of all left-handed students at APSU is between 9.13% and 20.87%. Remember, when I do the calculations, guys, I use decimals. But when I am writing it down or making my analysis, I use the percentage. That's how we go back and forth here. Thank you.